So number 5 is our exponential function rule of integration. So exponential rule. So differentiation, we have learned what? We have learned if we have a equation y equals to e to the power x, differentiating that e to the power x gives us what? Simply e to the power x. That means it doesn't change. It remains whatever it is. But if we have, let's say, some power there, like it comes in front, it gets multiplied with it, but still it remains same. So let's say e to the power 2x is there. So if we differentiate that, we have to bring this, like we have to differentiate that at first, or let's say we have to differentiate this at first, which is e to the power 2x, differentiating simply the outer function, which is e to the power 2x. Here we have two functions, isn't it? Remember, we have g of h of x, that means function inside function. So this is sort of something like that. E itself is a function, then 2x is inside it another function. So differentiating the outer function gives us simply e to the power 2x. It does not change. It does not change. Okay, it remains whatever it is. Now differentiating the inner function gives us what? We have to differentiate this d of 2x divided by dx. That gives us e to the power 2x times 2 times differentiating x means what? X to the power 0, isn't it? So x to the power 0 is what? 1. So simply we can write e to the power 2x times 2. So that gives us 2 into e to the power 2x. So that is our basically differentiated value. That means over here, what actually happened? We differentiated the outer function. Again, we have to differentiate the inner function there. Now, differentiating that x with respect to x gives us what? 1. So e to the power x times 1. Now, writing e to the power x and e to the power x into 1 is the same thing. Now, if we have, let's say, e to the power x square, then we would have simply also like done the same thing, differentiating the outer function first, which is e to the power x square, which remains same. Now we will differentiate the innermost function, which is dx square by dx. Okay, so this should give us e to the power x square equals times differentiating x square becomes the power comes in front times x to the power 1. So 2x e to the power x square. Now this is our differentiated value, isn't it? However, one thing remember, if we have, let's say, y equals to e to the power x plus some c constant, now dy by dx is what? E to the power x plus that constant, differentiating that constant becomes what? 0. So writing 0 and not writing 0, same thing. But let's say instead of c, we have a 5 here. That will also give us 0. Instead of 5, let's say we have 100, 1,000, or million, billion, whatever it is. If we have a constant there, differentiating that would give us 0. That means if we have this differentiated value, and if we want to integrate this differentiated value, let's say like integrating, we are trying to integrate our e to the power x dx. That means what? Our initial value was it like there a c added, or was there a 10,000 added, or 1,000 added, or 500, or million added, trillion added? Whatever constant was added, we don't know. So simply, like since we don't know, we have to simply add a constant c here to generalize like all sort of possible results, because c could have been also 0. C could have been like any random constant number, because all constant number should give and follow the same structure. So integrating this gives us e to the power x, okay, e to the power x, and sorry, e to the power x plus c. Okay, so this is our answer. Now, what about this one? E to the power 2x. Just a minute. Yeah. So why it got hanged? Just a minute. Give me a second. Wait a minute. I'm coming back. Sorry, it got like stuck there for a moment. Now, as I was mentioning, that what about this one? E to the power 2x. So e to the power 2x, then we have e to the power x square. This sort of structures, isn't it? So different, like integrating them, differentiating this gives us 2x e to the power x square, while this gives us 2 e to the power x. Now these themselves have some other concepts which we will be learning in future, but for now we'll be sticking with the simpler one, because for understanding purposes the simpler ones are right now better. Okay, so we'll be dealing with them in future, but for now we'll be dealing with the simpler ones so that like we can understand how things work at first, because at the very beginning if we deal with the difficult ones, it becomes difficult for us to get or stay motivated to do the future ones. Okay, now that means this, for this equation y equals to fx, y equals to x, y equals to ex, or e to the power x. If we simply integrate this, integrating this, well, let's say this is f of x. This f of x, integrating this f of x with respect to dx. That means e to the power x dx equals to simply e to the power x plus c. Okay, so that's our answer, because from our differentiation we got to know that differentiating e to the power x gives us e to the power x, but there could be a constant there as well. It might be 0, it might be any value. Okay, positive, negative, any sort of value. That was our rule number 5. Finally, we have come to our so far the last rule, which is our 6-number rule. This is trigonometric function or trigonometric integration rule. If we go now. Now, trigonometric function is like simply it implies in a similar concept as we have learned in differentiation. Let's recall the portions from our differentiation part. We have sine x. That means differentiating this dy by dx gives us what? Cos x. And we have, let's say, y equals to cos x. Differentiating this gives us what? Negative sine x, isn't it? Also. So if that's the case, then also remember, if we have y equals to sine of x, and there's also a, let's say some 5 added to it, like this 5 is not inside this bracket, rather outside of this bracket. So y equals to, or this can be written as similar way, so 5 plus sine x. Okay, differentiating this should give us 0 plus cos x. That means what? Simply cos x. See, these are the same thing. That means having a constant added there and having no constant is a similar sort of result. That means what? If we go in the reverse direction, that means if we integrate this cos x to sine, like if we integrate this cos x, it could have given us sine x as well as sine x plus 5, or some sine x plus million, billion, trillion, whatever was added. That means we don't know actually what was the constant there. So simply going in the reverse direction or integrating cos x give us what? Sine x plus some constant. Okay. Now, what about negative sine x? That means integrating negative sine x should give us what? Cos x plus some c, isn't it? Now, integrating negative sine x give us cos x plus c. But what about then positive sine x? That means if we can use some sort of, like, let's say, equation here, we can form some equation here. So if, let's say, integrating negative sine x, or let's start with the beginning. So y equals to, let's say, cos x we have. So differentiating cos x give us what? Negative sine x. That means differentiating dy, or sorry, integrating dy with respect to, I mean, integrating 1 with respect to dy, because here we have a one here, as we have mentioned in the last lecture as well. So you can see, go through the last lecture to like have a clear idea why I have introduced a one here. So dy equals to negative sine of x dx becomes what? Because negative, like differentiating negative sine, sorry, negative differentiating cos x gives us negative sine x. That means integrating negative sine x should give us what? Cos x, and there it doesn't yet, because we don't know actually if there was a 0 here or a 1 or 1000 or whatever it was. Like we could have also gotten this answer from other constant values, like if other constant values were added there, we could have, like we would have gotten the same result. So to be on the safe side, we would be giving a constant, adding a constant here. Okay, now if that's the case, that means integrating or y is equal to this value, isn't it? So that means what? Integration of negative sine x dx is what? Cos x plus c, isn't it? So bringing that negative in front gives us sine x dx equals to, like bringing negative 1 in front as if like we have, let's say 1 here, negative 1 multiplied with this term. So we have a cos x plus c here. So like subjecting this integration of positive sine x and taking all other things to the right hand side gives us what? If we have negative 1 multiplied to the left hand side, that means if we move it to the right hand side, what will happen? It will like divide it, or it will be on the denominator. So negative 1 goes on the denominator. So this negative 1 dividing negative 1 means what? Minus, like minus comes in front, and we have cos x plus c, isn't it? Because having minus on the bottom one, like having minus 1 divided by minus 1 or getting multiplied by minus 1 is the same thing, isn't it? So simply closing the breaking of the brackets give us minus cos x minus c. Now minus c. Now, as I mentioned earlier, to generalize things, y equals to mx plus c, we tend to give a positive sign in front of c. Now c could be any sort of value. It could be positive, negative, 0, anything. It could be a positive 5, it could be a negative 5, it could be a 0, anything. Okay, so that's why instead of writing this negative c, we would also write negative cos x plus c, because that's much more formal and much more like representable. So that means what? The integration of positive, like since integration of negative sine x is dx, negative integration of negative sine x is cos x, that means integration of positive sine x is negative cos x plus c. Okay, or simply say, if integration of negative sine x is cos x plus c, positive cos x plus c, integration of positive sine x is negative cos x plus c. Okay, so if we write this clearly, integration of sine x dx is equals to minus cos x plus c, integration of negative sine x dx equals to what? Cos x plus c. Then we have an integration of cos x dx equals to what? Sine x plus c. Okay. Now, some other values or some other portion here we have is, what is the integration of tan x dx? And another one, like these are the common one. So another one is integration of sec square x dx. Okay. So what are they? Now, as I mentioned earlier, the last class, that tan x is what? Tan x can also be represented as sin x by cos x, isn't it? So if that's the case, that means okay, before coming to this, let's recap a portion of differentiation from our differentiation lectures. So remember, we have y equals to ln ln of x. Now when we differentiate that, what do we get? We simply bring whatever is inside this ln to the denominator, and we also differentiate whatever is inside the denominator. Sorry, whatever inside is that inside log with respect to x. Okay, so that give us 1 by x. Now, if we try to understand this much more clearly, we have to change the power of x here. So let's say y equals to ln of x cube. So differentiating this gives us, the process is something like that. Whatever is inside this ln, we will bring it in like towards the denominator. So 1 by x cube. Now multiply it with the differentiated value of whatever is inside this ln. So that means 1 by x cube times x, 3 comes in front, 3x square, isn't it? So 3x square by x cube, that gives us what? 3 by x. So that's our result, isn't it? So that means if some ln of x cube is differentiated to get the value of 3 by x, that means integrating this 3 by x should give us the result of what? X cube, isn't it? Because that's what like we get, or what should we like what we should have gotten, isn't it? So that means actually like writing this in the reverse engineering process, we get from ln x cube to what? To 3 of x square by x cube to 3 by x. Now how did we get this? Because we differentiated this, the whatever was inside comes in the denominator, and differentiating the inside value gives us 3x square. And now we simplified it to get this one, isn't it? So that means the reverse is integration, isn't it? Now, if instead of, let's say, instead of x cube, let's say we have a cos x inside, then what should have happened? So simply whatever was inside should should come in the bottom, isn't it? So differentiating this, so it's simply dy by dxing. So dy by dxing here gives us what? We should bring the whatever inside towards the bottom, towards the denominator. Now multiply it with the differentiated value of whatever was inside. Now what was inside? Cos x. Now differentiating cos x gives us what? Negative sin x. So negative sin x divided by what? Cos x, isn't it? So like bringing negative in front, having sin x by cos x. I mentioned in the last slide that sin x by cos x is what? Tan x. So negative tan x is this, isn't it? So that means integrating negative tan x should give us what? Integrating negative tan x. Remember, negative tan x. Okay, integrating negative tan x should give us positive ln cos x, and there should also we add like a positive c constant here, isn't it? Because remember, anything we integrate, there should be a constant in like c there. This is the like actual form of like indefinite integration. Okay, since we don't have a limit here, and about limit we'll be learning in the future lectures, but for now, remember, for indefinite integrals, we have to add a constant c in every of the like, integrated value or integrated expression. Now, if that's the case, what should be the value of positive tan x then? Positive tan x should be then like, according to this rule, positive tan x, the integration of positive tan x should be what? Negative ln cos x plus c, isn't it? Let's verify this. Let's differentiate this again. Negative of ln cos x. Negative of ln cos x. Differentiating this, or dy by dxing, gives us, we will keep the negative in front. We'll bring whatever was inside the denominator, and we'll multiply the differentiated value of the inside function. This should give us negative 1 by cos x into negative sin x. This negative gets cancelled out, and this becomes sin x by cos x. And we know from trigonometric equality, or as I mentioned earlier, that sin x by cos x equals to tan x. This is known as trigonometric equality. Okay, trigonometric equality. That means trigonomically sin x divided by cos x is equal to tan x. So this is actually known as tan x. Okay. So that means inverse or integration of tan x is basically what? Negative of ln cos x plus c. Okay. This cos x is inside that ln and that c is outside of that ln. Okay? Ln is the natural logarithm function. Okay. And one thing remember, inside ln, only positive values like can be placed. Okay. That means this cos x must be a positive value. So in mathematics, we represent that all possible positive values as a modulus sign. Now, what is a modulus sign? Modulus sign is something, let's say we have x here, and x can be any number, any natural number. That means -5, 0, 5. That means from negative to positive, any values. But we want to restrict this value only for positive values. In that case, we will just simply give two bars to the two side of the, like two vertical bars to the two side of the x. This is known as the modulus sign. Okay. Similar way, we will place this modulus sign in front and in the like in the end, in front and in the end of the this cos x. That means this is a must be a positive value. Okay. So that's basically the trigonometric integration of tan x. Now come to the last one, which is sec square x dx. Now, in our last lecture, I have mentioned that sec x is simply 1 over cos x. Okay, that's what sec x means. Now, integrating sec x square x, there is like it has a deeper understanding and a deeper meaning, because just simply writing 1 by cos square x and doing calculation won't give us the correct result. So for right now, for now, just remember that integration of sec square x is simply tan of x plus c. We will learn in future in maybe pure mathematics 3, we will learn that how this derivation actually comes. But for now, just for the sake of doing maths, you have to know this, because it's a very complex, like sort of a complex understanding. Like to understand this concept or derivation, we have to dig deeper. And in order to dig deeper, you have to know a lot of things. Like for example, if you want to swim very deeper, you have to know at first how to swim at the like surface. Then you have to have a lot of gadgets and gears. Then you have to dive inside. So in order to dive inside, at first you have to know how to like swim in the surface. Then you have to prepare with our gadgets and gear. So then we can like dive inside. Okay. So right now, know that integration of sec square x with respect to dx is basically tan of x plus c. Okay. So that's basically all the rules we have. Okay. Now I would give some like homeworks. So it will be better for you if you are able to do it. So the first one is 4x cubed minus 2x squared plus 5x. I've given some homework in the last lectures. We'll be doing it together in the next lecture videos. So the second one is f of x equals to 2 sine x. Okay, so integrate all of them. Integrate all with respect to x. Okay. Then we have f of x equals to 1 over 2x plus 1. That is 1 divided by 2x plus 1. Then we have f of x equals to 1 over 2x plus 1 square f of x equals to okay, do this 4 at first. I will see what other sums we can do with this much of knowledge. Okay, so that's all for today. Inshallah, we'll be having more practices in the next class. So then, take care. Allah Hafiz. Assalamu alaikum.